Good afternoon, everyone. Welcome to the monthly Connexus webinar series. And this month, backed by popular demand, we're happy to have the gentleman from Omega ATC back to talk about using data science to proactively manage the connected C-store. Next slide. Our agenda today, I'll go over a few housekeeping items, talk a little bit more about our presenters, a little bit about Connexus. We'll obviously go through the presentation, and then we'll have questions and answers at the end. Just a reminder that this webinar is being recorded and will be made available in approximately a few days. And you can find them on youtube.com if you go to Connexus Online, or you can go to the Connexus.org website under Resources and Webinars, and you can see some of the past webinars as well. If you complete the survey link that you receive at the end after the webinar is concluded today, and you complete the survey, you will then receive a link to the presentation. So if you want a copy of the presentation, please look for that email and complete the survey, and then you'll be provided with that link. As a participant, you are on mute, and we do ask that no vendor-specific questions. So please ask your questions using the GoToWebinar interface as that little question session. And if you are using any of our webinars for continuing education credits, please contact Allie Russell for a certificate on webinar attendance. Our host today, as I mentioned, is Ms. Allie Russell, and thank you, Allie, for all your coordination and keeping us going. I'm your moderator. I'm Cara Gunderson. I am the chairman of the Data Security Committee. My day job is the point of sale manager at Citgo Petroleum. We are very, very excited to have back by popular demand Ashwin Swamy and Thomas Duncan, and they are very smart gentlemen from Omega ATC. So Ashwin is the director of cyber resilience, and Thomas is the senior security strategist. So gentlemen, welcome back, and thank you again for all the great information you're going to share with us today. A little bit about Connexus. We are an independent, nonprofit, member-driven technology organization. So for instance, there's a very small staff, and most of the standards are set by volunteers, and such as myself, such as Ashwin, such as Thomas. And Connexus is really an advocate for our industry. They also set standards for data exchange, security, mobile commerce, and they help provide vision on emerging technology and trends. So as I mentioned, they're very much an advocate for our industry and also for all of us in the petroleum industry here in the U.S. We've had a great webinar schedule, and this is the past webinars that we've had in 2019. And upcoming, we have Easy PCI, how to make your PCI attestation easier by the folks at Hughes. In November, we're going to be talking about the applicability of DSS requirements for merchants and the new managed network service providers that many of the point of sale vendors are bringing forth, and Sam will be sharing that information. He's with Control Scan. We are looking for some webinar content December 5th and 12th. And so part of that survey link that you'll be sent to would be information on future webinar topics. So please feel free to complete that. And then in January, Cybera will be providing us with their expertise in the webinar as well. If you're going to next week, please visit the Connexus folks at booth 3755. And we really want to thank all of our diamond sponsors. And now, Ash and Thomas, I'm going to hand it over to you. Thanks again, you guys, for sharing your great content and knowledge with us today.
Awesome. Thanks, Cara, and thanks, Allie, for hosting once again. And thank you, everyone else, for joining, especially in what must be a busy week for folks who are going to the NACS show. As Cara mentioned, the title of this presentation is Using Data Science to Proactively Manage the Connected C-Store. Over the last year, Thomas and I have had an opportunity to see how retailers are starting to think about implementing IoT and other connected devices into their stores. And based on conversations with retailers, we have noticed that while there's certainly a ready supply of interesting and potentially very effective IoT applications out there, adoption has been fairly low so far. Those devices that have been adopted have been pretty minimal in function, things like temperature monitors and label printers, and nothing that is necessarily considered groundbreaking. But given the overall focus that we've seen from Conexxus over the last year about the fourth industrial revolution that we'll be talking a bit more about shortly, as well as the conversations that we hear on the news, whether it's surrounding Amazon or Microsoft about the level of automation and the use of data that is coming to retail, and really just the general surplus of solution offerings out there, one would think that we would see a greater and more aggressive adoption rate of connected devices in the petroleum retail environment. Of course, there are some other factors like outdoor EMV that have put these types of projects on the back burner. But nevertheless, what we've heard from various folks in the industry is a general sense of caution around implementing IoT. And so in today's presentation, we're going to talk about a few different items related to effectively managing connected devices in the petroleum retail environment, and especially being able to effectively manage those devices using data. So first things first, I definitely would like to talk a bit about what some of the difficulties have been around managing IoT devices. We'll then jump into some industry analogs that will help us understand how we can navigate a digital transformation. So that's really looking to energy and utilities, transportation, healthcare a bit, and other industry verticals as well. And with that understanding in mind, we will then apply those analogs back to the petroleum retail environment and walk through some fairly simple use cases but that we hope can give us a generalized approach going forward. And lastly, just some tips for teams that want to experiment with predictive maintenance approaches on their own, outside of any formalized projects. How do people get started? We'll have a few ideas for that. So first thing, really talking about the fourth industrial revolution. I know a lot of these buzzwords are thrown around, but this is specifically taken from an article that Gray Taylor wrote last year. And so when we're really thinking about the 4IR for short, we're talking about 6 areas. One is big data, so being able to have passive sensors that are collecting data in real time, so that way it's not having to be manually collected. And that big data is having so many data points that you can then reliably start thinking about machine learning and things of that nature, regression, more advanced statistical applications. The second is what I just talked about, Internet of Things, so devices that are either on network or they're communicating via Bluetooth or RFID, smaller devices that are lower power and that are meant for more narrow range of functions. The third is, AI, and that relates back to big data. The fourth is robotics. The fifth is autonomous transport. And the last is augmented reality. And so just to really touch on this graphic here, if you're talking about the first industrial revolution was the steam engine in the 19th century, and then getting into mass industrialization with automobiles. After that, we have computers and automation happening in the 1960s. And then finally, cyber physical systems, which is what we're talking about in this fourth industrial revolution. And so, like I said, we will be mainly touching on Internet of Things. So one thing that not just in C-stores, but that we're actually seeing trends across industries is that IoT adoption is in a holding pattern. So what you can really see here, and something that Bain releases year after year, is basically a continual update on what they see the adoption rate to be in subsequent years. So in that figure 1, they say IoT outlook for 2020 has dampened, but long-term targets remain bullish. And frankly, we've seen similar reports in previous years. From that Bain report, a specific quote is there are concerns over integration issues, in particular technical expertise, data portability, and transition risks, which have become more acute over the past 2 years. Continuing on, Is there a little bit of static on the end? I maybe want to stop for
There's
a moment.
a lot of static. Yeah, we're having some problems with GoToWebinar today, so we sincerely apologize. Yes.
Okay, maybe
It kind of comes and goes.
Okay, let's give it another shot. Is that better?
Thank you. Yes.
Okay. Well, keep me updated if that becomes a problem. Good thing I haven't hit the good part of the presentation yet. So
we'll also try and get a hold of GoToWebinar tech support. Thanks.
yeah, as a part of this whole effort here. Connected devices can also be phones for that matter. So either way, what we are seeing across industries is kind of this continual year after year update regarding the outlook of IoT. So you'll see all over the news and in different articles what the market potential is for IoT and things of that nature, but in reality, it has yet to be put in play. Now, what is interesting, though, about the update from Bain is it's not the same exact report from companies that are looking into IoT applications from previous years. Now what we're really seeing is that businesses believe in the business case of various IoT applications, and we'll talk about that more in a bit. They believe that it can offer some ROI, but after piloting and evaluating some of these solutions more closely, the concerns have a lot more to do with barriers to implementation, things that related to integration issues, as this quote says, technical expertise, data portability, transition risks. That's really where the focus has come. And that's actually also what we are hearing directly from retailers today. So, a few jokes, but I do think that it kind of captures sort of the general tone when you speak to an actual IT team about a variety of IoT applications that sound maybe pie in the sky. Can I interest you in a firewall for your toaster? Now you have, connected devices that are fridges and toasters and shelves and, on and on. And in this cartoon, they're really pointing to potential security risks around IoT, which we'll touch on more momentarily. The second is, we have to go out for dinner. The refrigerator is not speaking to the stove. So there's the notion that, okay, managing C-stores is hard enough as it is, especially if you're a managed network service provider or an IT team that is managing the network. And now you're talking about dropping maybe 30 security cameras or, Tom, you've been working a lot more closely with these devices. Can you think of some other applications right offhand that we're seeing in retail?
Sure. Recently, we've seen increased use for monitoring temperatures of refrigeration units. A lot of people are saying that in the event that they get audited, they need to provide information and facts about the temperature of that area during a certain given point in time.
Right. And obviously the logistical challenge with C-stores is that even if it's a 5-store chain or 10-store chain all the way up to 100 plus and 500 plus, it's really being able to remotely manage stores. We can't put ourselves in a situation where a small little device in a store requires a site visit. And so what that really means is that the level of reliability around a device that's required before it can be adopted is quite high, given that logistical challenge. Now, to put that into focus, there's a pretty funny quote from Elon Musk this year, just to give some context. In end of 2018, in his Q4 quarterly earnings call, Musk talked a lot about how probably the biggest gap in their company was servicing Teslas, especially in Europe, in Germany and Norway. There were less than a service station per 200 kilometers. And, that was starting to receive a lot of blowback from customers in those nations. And so he says on this call, and I have to read the quote out because it's I can't tell if he's being tongue-in-cheek or not, but he says, "I meet with the service team multiple times a week and get daily updates on the reliability of the vehicle. The best service, of course, is no service. That's the vehicle, just reliability and quality being so good that service is rarely required. That's what the main goal is, eliminate the need for service." And while that's a little tongue-in-cheek and just saying basically you can just keep building things better and better so it never has to be serviced, to a certain degree, it does speak to how we have to think about IoT, that they can't be these and other connected devices. They can't be systems that are put into the field that require regular maintenance and service. Otherwise, it's not going to be tenable. So that kind of brings us to the predictive maintenance paradox. It's my own term, but reading off the Bain quote again, and then there's a graphic after this. Bain says, predictive maintenance is the prime example of a use case that vendors are ready to deploy, but customers are less excited about, as shown in the middle right panel. Its decline, and they're referring to those previously shown graphs, its decline in attractiveness indicates customers face implementation barriers. And so to touch on predictive maintenance, what we've seen in the industry this year is all vendors, point of sale system, pump, back office systems, and other IoT device vendors really trying to make available through central managed portals, through various types of logging, asset data and performance data. We're seeing a lot of conversation around how can we measure, point of sale system failures, application failures, reset events, things of that nature. You'll hear similar things for pumps. How can you pull data to ensure that they are reliable? Now, the paradox is a lot of times to facilitate that data collection and that predictive maintenance, you need to have other IoT devices, potentially, or edge devices on the network. They can be smaller Raspberry Pi based devices and other type of form factors that Thomas will talk about later. But that introduces a paradox. One is we desire the ability to determine exactly when and why equipment or operations are at risk of failing in order to reduce overall maintenance costs. And then in order to identify these signals, we require IoT devices to provide us with the data we need. So if we're talking about operational failures, maybe food going bad, maybe we're talking about a fridge being open and potentially having additional perishable food and waste. And so we're trying to prevent those operational failures, but then in order to prevent them, it requires additional devices that may have their own operational failures. So that's the paradox, that IoT devices, and I'll insert a clause there, unless they're properly vetted and tested and the enterprise is ready to handle them, they inherently increase the number of failure points in the retail environment and therefore can increase maintenance costs. So then we have to kind of then take a step back, and this is what we've heard from several retail IT teams doing, weighing the business case versus those transition costs. So the business case is obvious. You want to be able to, and I'm speaking specifically to those predictive maintenance applications, you want to be able to mitigate operational issues. You want to be able to remotely manage the store more easily, and not just systems, but operations, things like food service, and we can go down the list. We want to be able to deliver a better customer experience, such as, kiosks or, self-service machines, whatever it might be. We want there to be more safety improvements, whether that's physical security or store safety or food safety. We want to be able to reduce those device failure rates and reduce resources, make better decisions. And, so those areas really apply across the full range of IoT. But then the transition costs look like potentially way more frequent site visits. I mean, imagine deploying 10 more devices per store if they're a certain type of sensor across 100 stores. The management hassle, simply to be able to keep track of what all the devices are doing. Increase in the number of operational issues and device failures, more or less related to the first bullet. And then you have things like, going to the last bullet, security issues, so making sure that the devices has the right communication protocols, making sure that the cloud infrastructure has been properly audited if it is a cloud-managed device. And then, of course, network issues, making sure that adding a bunch of devices does not include or create all kinds of latency on the network, cause outages, whatever it might be, and really get in the way of other critical processes. And so, before touching on Microsoft here, I think the original IoT discussion was about, does the business case make sense? Can we actually find a use for these advanced applications if everything works? I think that question in a lot of ways has been answered, both because retailers have taken the time to evaluate these applications and these devices and work directly with vendors to better define the use cases, but also vendors have really gone to town to make sure that they are delivering solutions that make sense for where retail is headed. So now, like I said, the conversation has really moved to one surrounding reliability. Now, before we really get into, looking at the use cases and touching the data, I should say that, okay, because there may be some reliability issues, that doesn't really mean that we can turn away from the potential applications of connected devices in the retail environment. Just this week, and if you just search Microsoft, this will be one of the top news items, if not the top for the company. They've introduced Microsoft Dynamics 365 AI-driven insights applications, and it's their vision for the future of retail, basically their Amazon competitive set of tools. And despite the fact that this Microsoft Dynamics set of tools that they released have a wide variety of use cases, the specific woman who is involved in leading this effort, her primary focus is retail. And she's talking about things like analyzing data from video cameras, and then once again, touching some of those other use cases we already mentioned, like improving the register experience, making sure there's a cashier there, monitor freezer temperatures, all of those things. And so that brings the question, if retailers and if all of us as an industry, we can't just avoid the conversation as to what does a technology roadmap look like for implementing IoT and connected devices, the question we have to ask ourselves is, how can we navigate this digital transformation in such a way that we can realize the positive benefits and avoid those negative transition costs we talked about? And so what I'm going to do here is really just briefly mention a few industry analogs, because some other industries are a few steps ahead of not just petroleum retail, but retail in general, and really take some of the lessons learned there and then apply them back to the retail environment. So first, manufacturing. As you can imagine, being able to predict at a very granular level device failures, which we'll call condition-based maintenance, that you're maintaining things based on the actual conditions of the devices rather than just on a service schedule. There are a lot of lessons to be learned from manufacturing around condition-based maintenance that we will apply once again to connected devices. The second is energy and utilities. I would say that smart grids and everything that's been happening around the updating of our utility infrastructure is directly applicable to what we're dealing with from a networking standpoint. And so when we think about outdoor EMV, I'm going to pause for 1 second, actually. We're getting a little bit more of that static. Is it okay?
Yes.
I'll just keep going.
Thank you.
Sure. Energy and utilities, we're talking about demand modeling, outage management, things of that nature that when we're looking to outdoor EMV and we're looking to all these new devices being added to the network, we're going to have to take a far more data-driven approach the way the utility companies have, even when it comes to looking at local store networks. And then the third area, if we're looking at transportation and advanced safety systems, what we're talking about there is self-healing actions. So, there's a Ford picture there, and even though that's a self-driving car, even regular Fords that are on the road today, if you're drifting in the lane, it detects that and then corrects immediately to make sure that, you're staying in your lane and not falling asleep at the wheel and things of that nature. And so just to summarize that and to provide more accurate definitions here, we're going to look at condition-based maintenance, identifying features that can accurately determine the condition of an in-service equipment in order to estimate when maintenance should be performed. The second is outage management, identifying features that can help predict causes of outages and poor network performance, and then effectively model demand in order to help plan ahead for those 20 connected devices that might be jumping onto a store network, and making sure that sites are ready for such major changes. The third is, I talked about those advanced safety systems. In our case, it's really self-healing, implementing backup and secondary processes that will automate responses when threats and issues arise. And so a couple of notes here, just to give some greater context. The petroleum retail environment is really critical to our country's resilience overall. Something we talk a lot about is we should be thinking in terms of resilience and not just in terms of security. There are many different types of threats that can impact a C-store, whether that's weather-related, physical security-related, cybersecurity-related, or simply operationally. And so we're trying to take a look at this overall picture from that broader standpoint. This picture is simply talking about how, certainly this year with, I'm forgetting the name of the hurricanes right now, Dorian, and, in the past, Harvey and Irma, C-stores are looked to as really the only locations, publicly available locations, that are providing supplies and goods 24/7, even during inclement periods. And so that's why, as of late 2018, FEMA and CISA, the Cyber and Infrastructure Security Agency, they've defined these 16 critical infrastructure sectors. I highly recommend you go online, look at the DHS site, and it really gives a sense as to how the government and DHS is really looking at the overall risk of our infrastructure in this country, both from a cyber standpoint, but also terrorism, climate, all these things. And C-stores actually fall under 4 categories: transportation, emergency services, energy, and food and agriculture. And so I bring all that up just to make clear that the bar for making sure that the stores are fully operational is getting higher than ever before, for reasons that go beyond just trying to tailor personalized customer experiences. And so, without further ado, let's just jump right into it. With condition-based maintenance, we're talking about using key signals to prioritize device maintenance and preempt device failures. We're asking ourselves the question, how can we forecast device failures and avoid unnecessary and costly device maintenance? So when we're talking about IoT devices, there's really a set of steps that we can look through, and we're going to get into real data in a moment as to how to assess the device before you even buy it, making sure that it has good parts, things like a good battery, a good processor, a good network adapter, memory, and hard drive. Of course, making sure that it's set up for proper security. If it's a cloud-managed device, making sure that the cloud environment has been audited for some sort of legitimate compliance. Speaking to manufacturers allow us to set baselines and thresholds ahead of time. You can look at mean time to failure, mean time between failure. Manufacturers and vendors should be able to provide those statistics, especially when it comes to hardware failures. And so based on this information, when you're looking to adopt and implement IoT, you can start putting together an IoT device maintenance plan. And so now we're going to be starting to talk about what are the potential features that can allow us to predict failure ahead of time. Let's just say a device is saying that its lifespan is 2 to 5 years. That begs the question, how can we make sure that lifespan is hitting that 5-year end and not that 2-year end? We don't want to be replacing devices in 2 years. And so just using some domain knowledge, potential features are device temperature, device CPU and memory utilization, battery and power consumption, other device alarms, and previous maintenance activity. And so are there situations where the data can help us to notice patterns related to outages and connectivity issues, especially when patterns are non-obvious? That's the question we're going to be asking ourselves. So Thomas, you take it away, because I think what you're going to be showing is some examples for how to collect this information.
Sure. Thanks, Ash. One of the first things we need to do is identify how we're going to get this information, what devices we're going to use, what APIs we're going to be using to do this, or other network technologies. How are these devices normally on the network, what the communication standards look like, how frequently we're going to be pulling this information, and what the effects of that frequency are on the network. Also setting thresholds for alerts, and some of the tools that we can use to analyze this information in the cloud. When you're assessing a tool or a service provider, there's a couple things you want to look at right up front. When they say they have software that is going to be installed on your network or on a system on your network that is going to be collecting information, transmitting it locally to the cloud, first thing you want to do is look at what type of communication protocols are they going to be using. Are they using some of the more best practice industry standard ones, or do they have outdated protocols mentioned, SSL, Telnet, FTP, some things that you want to be careful of when you're selecting these vendors. All of this information has to be stored in the cloud. So what you want to be able to identify is where these servers are stored. Are they stored in a hosting environment that is popular? AWS, Azure, they've got, they're highly recommended. There's statistics around their security and information that's available publicly. Do they have a vulnerability management program? These applications that are hosted in the cloud are publicly available. So any person that has access to the internet is going to be able to find out or access that public IP or that public interface. So you want to make sure that it is protected, similarly to a lock on your door. Anyone that has access to your house can walk up and have a knock on the door, but can they get in? If we have to install additional devices on the network, we want to make sure that we have proper segmentation. Making sure that these IoT devices, that a lot of them come from China. I don't want to say you can trust them 100% of the time, so you have to be careful. You don't want those devices to have any sort of malware on it when you get it, but if they do, you definitely don't want them in your CDE. So keep them isolated and monitor the traffic coming off those devices. Make sure you can identify trends in that network usage. So there's a couple different ways we can collect this data. One way that we see is having a network device or a probe sitting on your network that is able to query different devices, IoT sensors with different protocols, and take that information, analyze it, and send it to the cloud. You can have dedicated devices that do this. A lot of companies that have IoT solutions for a set of things such as monitoring temperatures and producing labels for your your quick service restaurants. They have packages that work together where there's a network probe that sits there, and all of the other sensors transmit data back to that, and then that sensor itself will relay back and forth to the cloud server rather than every sensor individually sending that information to the cloud server. There's also ways to collect data by installing software on these devices. We call those agents, and there's also ways to collect this information without agents. So you'll hear these terms a lot, agent versus agentless monitoring. If software can be installed on the endpoint, generally we see that we're able to grab more information. That information can be more detailed. It's not necessarily up to what protocols you have, what networking protocols you have access to, but actually being able to query that hardware and that software itself because you have direct access to that system. Other ways we can do this is through agentless monitoring, and this is the use of more available protocols, WMI, SNMP, syslogs, APIs, which everyone knows is becoming more and more popular, and you'll hear that tossed around a lot. And there's other ways mentioned. People can get creative with it. You can go to the next slide. So there are some tools that can help you run or collect this information without having to do too much work yourself. This is actually something I was able to download and install a free trial of to show just some example of the data you can collect just by running SNMP queries. So you basically download a probe, which has a list of OIDs, which are object identifiers that SNMP uses to determine what information you need to send back and forth. So those are pretty standard for a lot of networking devices, those OIDs. So when we downloaded this probe, it had a list of things it needed to gather. You just checkboxed the ones you wanted, and it went out and discovered all of this information. Same thing with printers. Printers are an interesting example because, working with a lot of convenience store networks, the main device we see replaced seems to be the printers. We've got new printers going out every week. And being able to have some information about what those printers are doing. Are the paper's jamming often? Is the ink not, is it not losing its levels as fast as it is? Maybe there's some sort of, congestion on the printer head. So grabbing this information and being able to pull it to a central location and look at it allows you to create your own theories and prove those theories with some testing to be able to determine if the device is coming end of life or if there's problems with it. There are some more ways that you can collect this information. You don't have to purchase a tool. There's a lot of open source scripting tools you can use. I've just got a couple of examples of some scripting languages, Python, PowerShell, Bash, JavaScript, Windows batch files. All of these can be used for you to create your own SNMP monitoring or other type of monitoring. There's modules you can import. And there's plenty of walkthroughs online to where you can almost copy and paste what other people have created, test it, and implement it yourself. Just be careful and know exactly, have a good idea of what you're doing. Don't just go into it blindly. But there are free ways to get this done without purchasing tools. That information could then, you could query a device, pull the information back, store it locally, set up different monitors off what you're collecting, and then send those results to the cloud. So there are different ways that we can collect this information and transfer it, and it all depends on what the use is. So there's three general ways of sending this information to the cloud. You can monitor for alerts, which are specific events that you know are going to happen, such as a CPU, performance is above a certain threshold, so above 75% or below 2%. And you can expect those types of things. They're not unknown. That is useful if you want to pull a lot of information locally, but only send what is necessary for you to be alerted of certain situations, which minimizes the amount of bandwidth in use outbound and allows for more other applications to use that bandwidth. There's also continuous transfer models. So I'm taking this information and I'm just funneling it to the server in the cloud, and I'm going to keep sending that information, which is great if you're looking for very real-time information. Maybe if you've got that one critical system in your environment that you need to know exactly what's going on it all the time, this would make sense. The network traffic that it's sending, it might not be, the size of it might not be a lot, but the consistency, it's always going to be there. You can also pull information to your endpoint and create reports, or people like to store it in, CSV sheets, different things like that, where then you can analyze those results and set up your thresholds for alerts, but at the end of the day, send all of those results at once up to your server. Now, typically that will require more bandwidth, but for a shorter amount of time.
Tom, I have a quick question for you. Do you have a sense as to, can you give some examples as to what type of devices might be better suited for certain methods of polling? So certain devices you may want to poll every 5 minutes for data. Some other devices, a week is enough, a day is enough. What comes to mind?
Sure. When I think of say alerts that you want right away, so you want to be able to pull those every 5 minutes. And those could be things such as CPU performance, bandwidth usage, or it could be things that if you're monitoring for security events, you can query devices for different types of failed logins. You can get information received to you.
So I guess what I'm hearing is it's really about differentiating between immediate signs of failure, which you need to know about immediately, versus collecting information that can give you a sense of a potential downstream issue, and being able to use that information, which is not pulled every day or pulled as frequently, to conduct an overall risk management of your set of connected devices.
Yeah, that's correct. You got it, Ash.
Thanks, Tom.
So what are we going to use this data for? Let's take a look at an example such as monitoring how much bandwidth is being used at what time of the day. If we have that information stored on a server and we have historical information about that, it can help us plan some tasks out that might be more network demanding, such as security patching, downloading large updates from a server, sending content to and from the store for videos at the pumps, which are becoming more popular, or if you've got video boards in your store, something where there's media content that has some memory to it. Exporting information, and then vulnerability scans, that sends a lot of different packets out on the network and can increase the network latency. So if we have this information, we're able to review it and determine how much network use or bandwidth usage is happening during certain times of the day. So then we can schedule our tasks around there to make sure that we're not failing when we run these tasks. We don't have to rerun them the next day, that we're getting the most efficient results, or the best results from those tasks. We can also use this information to determine if devices are failing, if there's any inefficiencies. Maybe we notice that we've got our patching set up to go at 12 o'clock in the afternoon, but it takes a very long time for patching to actually finish because it's taking longer to download those files. So we can monitor those results to improve our store operations and efficiencies. So let's just take that example and roll with it a little bit. So say we've got just a simple graph of some network traffic in and out on the network. We can visually see there's some time closer in the morning, probably no one's in the office, there's a big spike, and then the traffic starts to increase a little bit. So since we have that information, we can put some common sense to it. There's more bandwidth available, there's less bandwidth available. And if we have this data at large, so we've got it for all of our stores for a greater time period, it really gives us insight into which processes are happening during which time and how much network, how much bandwidth those processes are taking up. So we could take that back to what we were talking about previously with, alerts, continuous data transfer, and our daily, weekly results. Alerts, if we, from that previous example, we can pretty much send out at any time, and we need those at any time. Since they take up small amounts of data, we're not really limited. Continuous data transfer, if we have that continuous data transfer going, we'd see that in our graph, and the baseline for our network bandwidth would be increased. And then, sending those daily and weekly results, if we want to make sure we can get those reliably, we want to find a good time during the day when we don't have a lot of network usage, and that those are going to be able to be exported and uploaded in a quick and efficient manner.
Great, thanks. So maybe just a few lessons learned from what we just discussed around condition-based maintenance. One is, don't just ignore devices because they're not failing. The data that they're putting out is useful no matter what, because even if they're not failing, they may not be performing optimally, which could be a sign of downstream failure. As an example, if a set of devices fall beyond the median range for memory, CPU, temperature, another feature, it's worth asking why. Can anything be done on that device to adjust it, to bring it in line with the other devices of a similar type? On a different note, if devices are performing well, they don't necessarily need to be worried about. They don't necessarily need to follow the same maintenance schedule as those devices that are not performing well. And then, like Tom talked about, really setting thresholds. So understanding what is meaningful, basically being able to set up alerts around meaningful thresholds that are related to the device. So that way you can contextually understand what might be a device failure or something of that nature. So maybe just to put put a cap on that, there's obviously a whole discipline around taking that data, that memory data, that power consumption data, CPU data, measuring it against the original benchmarks, the original mean time, between failure, and all those other metrics that the manufacturer might provide, and then use that to actually create fairly accurate models as to what the probability might be of a set of devices failing versus another set of devices. And that, at the very least, allows you to prioritize your maintenance schedules and understand what to really keep a closer eye on. And so, in the interest of time, I want to quickly go through some of these outage management examples. But I think the big takeaway with a lot of this is that it's easier and more effective to manage outages when there's a lot more information at hand, and not just a certain store had an outage and it happened at this certain time, and the downtime was a certain, for a certain number of hours or minutes. What we need to be able to do is start formally documenting a lot of information that we don't always see documented. So, what we normally see is if a store is being set up, for instance, and some determinations are being made around what the network requirements for that store should be, a lot of it relies on tribal knowledge. okay, if a store is in a remote location, maybe somewhere in the country, it's not going to have a good cell signal. Or, people say, okay, that store is with brand A, that other store is with brand B, and so on. Or that store is the one that has the food service and sells pizza. Or another store, that's the Verifone store, that's the NCR store, and so on. Kind of these general classifications that don't really help us identify real predictors of outages. So here are some additional information that is worth collecting and using to contextualize your network information and outage information. So site information about the building that it's in, the date, things of that nature. There's asset information, things about the specific devices that are on the network. There's the full network performance data and just how much more data can be collected around network performance to better predict outages. Then there's power data, because obviously there's a correlation between, power surges and outages and things of that nature, and then, connectivity outages. So having a single source of truth featuring a wide set of information can have a meaningful impact in being able to triage issues quickly between multiple parties, the service contractors, operations teams, IT teams, and by operations, I'm really referring to those facilities teams, point of sale system vendors, the managed network service provider, and anyone who's involved with security. And so just to give a sense of what we're talking about with these different sets of data, site asset data can go far beyond just, okay, I have Verifone at that store. It's these are the payment terminals, these are the scanners, these are the dispensers, this is the network configuration. Can go into things like serial numbers, vendor, model. And Conexxus has a great kind of site asset data definition, basically a kind of a glossary of terms that really fall under site asset data that definitely is worthwhile to follow. And so why are we going through all of this effort really just to collect data? Well, one thing is we want to be able to classify stores and classify events more effectively. So one other aspect of collecting data is when an event happens, when there's a power outage that happens or connectivity loss, are we classifying that in terms of what the root cause was determined to be during that post-mortem? Was it related to a power outage? Was it environmentally related? Was it human error? Was it a network bottleneck, hardware failure, software bug, and so on? Just a little bit more detail as to the other data types. You have information about the building, and then you have outage data. Apologies for not filling out all these fields. The Excel to PowerPoint transfer was rough. But, the ticket number, the start date, the end date, the store number, total duration, that's your typical outage data. Then when you say your site asset data, that brings in information about the actual devices at the store and what their versions are. Network data goes far beyond, oh, we were on backup, or oh, it was out. It's a whole series of metrics that really exist, especially today with a lot of network performance monitoring tools that exist, such as, and what was it called, Tom?
The example I was using was just from PRTG.
Oh, okay, it was just PRTG, all right.
Free trial for it.
And so, not to belabor this point, we want to use this data to be able to very precisely answer questions. What stores, when you're planning a new store, need multiple WAN connections? What stores need to have a certain wireless backup solution? What stores need to have a certain data plan? What stores need to replace power infrastructure? And what stores are lacking surge protection, UPS, what stores are older? These are all potential predictors of outages. And what you want to be able to do is essentially collect this data and start understanding relationships. I'm showing just a very classic example of exploratory data analysis, which is simply that when you're able to combine variables that would not normally be combined and then explore that data, a lot of very interesting insights can come about, such as maybe a subset of stores are a certain age. They're the 30-year stores, and you never knew that there was a higher frequency of outages compared to the age of the stores. And what do the age of the stores have to do with? Maybe it has to do with the the cabling. It's a Cat 5 and not something else, or it's there's not sufficient surge protection at the store. excuse me, things of that nature. If I can go back, we can look at things like certain stores are impacted because the temperature is higher in those stores, or the routing equipment sits in a metal case. You're able to pick that up if you have very complete site asset data. That lets you know that, okay, maybe the casing or however the network infrastructure is being stored actually impacts connectivity because the MiFi, the wireless backup, is basically, totally, covered, and that antenna is not free to run where the signal is best. Whoops. And so, something to really discuss and think about here is the difference between prediction and forecasting. This is not big data necessarily. We don't have terabytes of data, but that doesn't mean that you cannot forecast and reduce risk over time. We all like to dump on weather predictions, but the truth is that actually weather forecasts are not bad. They're better than us just guessing randomly. And so if we compare forecast versus prediction, sure, maybe algorithm A gives an exactly 2% increase in true positive detection of threat over algorithm B. But what we're trying to say is more of a forecast. We're targeting 80% of all servers of class Y to have a security grade of at least A in the next 3 months. Or we're targeting a certain number of stores to have a certain availability. We want the 6 nines instead of the 3 nines, things of that nature. That's forecasting that by identifying possible predictors, features that are related to outage or service, we can potentially improve availability overall. And so here are those unexpected relationships: connectivity failures versus backroom temperature, outages versus building age, outages versus food vendor, failures versus square footage, outages versus whether there's surge protection at the site. And then there's, of course, a variety of very granular, things that can be measured related to the network performance. And so just moving on, and we're going to touch on this very briefly just so we leave some time for questions. When we're talking about self-healing, what we're really talking about is being able to implement automation on systems that can introduce proper backups or mitigating measures in case of some sort of failure. As an example, the POS application failure. And maybe in the interest of time, Tom, maybe we can just quickly run through the case study and just kind of give a high-level description of what you did, and we can hit lessons learned.
Sounds good to me, Ash. So just to kind of go over the initial issue, there was a point-of-sale application that wasn't starting up when it was expected to be starting up. So we measured the baseline. How many stores is this impacting? How long was this going on until it was noticed? What was the duration of this impact? After, to find that out, we said, okay, we need to collect this information. We need to find out how often this service is not starting and on which machines they're not starting on. So simple things here, such as the name, device, state of the service. After you have that information collected, you can throw it up in your SIM and you can view that information. So you can clearly see here that, every Wednesday, about 25 to 30% of these machines were having issues starting this application. Go to the next slide. Okay. So after you determine, why this is happening or how this is happening, able to see that data, you can start to hypothesize, why do we think it's this way? Why do we think it's that way? What we've ended up finding out was that the service was relying on the SQL service to start, but the SQL service couldn't start because the amount of resources that were needed to start the service on boot were not there for SQL. So it was timing out and failing to respond. So we tested these hypotheses, made sure that what we were finding fit, and decided that we can implement our own self-healing actions or automated procedures to make sure that these services start consistently. A good example of that would be, okay, let's monitor the service. Is the service running? Yes, okay, we're good. We'll monitor again in 5 minutes. If the service is not running, okay, is the SQL Server service running, the one that's dependent on it? And then you can follow the chain from there.
So basically, there's applications for that. If a device is not responding, you can maybe automate reboots, remotely if you have like a power distribution unit. And so maybe just quickly getting to lessons learned here. I'll skip ahead. Key takeaways. It's worth implementing new connected devices if the business case makes sense, the devices abide by the proper security standards, and if the overall enterprise is prepared to manage the device following the implementation. Preparation includes ensuring that a wide array of data points is being collected, tracked, and made visible. It also includes having the right monitoring and operations tools in place to ensure that the data can be collected. It means having regular retrospectives and postmortems to ensure that any incidents and outages are being properly classified, so that way they can be studied retrospectively for patterns. And then you want to be able to perform regularly exploratory data analysis that can help us understand whether there may be issues coming downstream that can be predicted or forecasted ahead of time. That's basically all we had. We skipped over a few things, but I want to at least leave 3 minutes for questions. We'll be at the NAC show next week. If you find us remotely enjoyable individuals and want to hang out, feel free to reach out. And with that, we'll turn it back to you, Cara. Thanks for everything.
Gentlemen, thank you very much. As always, some great information, and we appreciate it all. As we mentioned, we didn't quite get to all of your slides as much as we would like. So again, please look for that survey email. Complete the survey. It's only like 3 or 4 questions, guys. It's not tough. And then you can get a link to the survey, or to, excuse me, of the presentation. So we do ask that you ask your questions via the GoToWebinar panel. And we have had a couple comments come in. You know, there's some folks out there that are using some different types of free services out there just to kind of get some of the basics covered. So we're happy to hear that some of you are taking care of business as you should. One of the things that while people are typing their questions that popped out to me was, you know, when you were going through the slide on vetting your vendors and your new vendors, you were talking about SSL and you were talking about Telnet and FTP being some of the older protocols. I guess I just kind of wanted to give a shout out to say, you know, don't forget to also assess what you already have existing in your stores, because those older technologies are certainly not secure, and some may argue the compliance of it as well. Do you have anything else to add to that, and any best practices on assessing your existing?
Sure. You know, following PCI requirements, it's good to always have that internal vulnerability management program in place, the devices on your network, and analyzing what ports are responding on. So if we see, you know, port 23, we know that there's a Telnet service running on this and it's listening. You know, if there are older technologies that require using that service or, you know, insecure protocols, it's best to isolate those on their own segment, maybe just communicating with what they need to for business, and setting up extra monitoring around those devices until you can put together a replacement plan and make sure that you're able to, you know, kind of upgrade the security posture of that system.
Yeah, it is, you know, in the petroleum industry, we especially see a lot of folks using a lot of legacy equipment, and with the upgrades to EMV, we're certainly upgrading our systems and upgrading our technology. However, you know, there's still some that linger out there, and so as you said, you know, make sure that you're doing a full assessment and making sure that you've got all of that buttoned up, because, you know, we've seen so many data breaches where they're even going through you know, other parts of the business, or even third-party vendors to get into the credit card data, so, or even sensitive data. And you know, with a lot of states introducing consumer privacy acts, I think there's like 12 states right now at least that have introduced that. So we have to be cognizant of the sensitive data with our loyalty programs as well. So. There are no questions, so thank you very much, gentlemen. We appreciate your time today, and thank you, everybody, for joining us. We look forward to talking with you next month about PCI. Have a good day, everybody.
Thanks, Cara. Thanks, Allie. Take care, everyone.